Okay, what is the current then through the diode? You need to calculate another in-between current before you calculate the current through the diode. The one that before even knowing what the question was asking, I marked on there. Okay, the total current out of the voltage source. How do you do that? KVL, or we use our node method shortcut, which is essentially the same thing, and that I, okay, is what? Start minus, so 5 minus 0.7 divided by 1, right? And we're going in milliamp. So that's 4.3 milliamps, right? That's this current, 4.3 milliamps. 4 milliamps are going here. So how much is going through the diode? 0.3 milliamps. Okay? That's it. You can start with an assumption that the diode is off, unless you can see right away that the diode will have to be on. Some problems you can just see. Okay? It's your intuition. Do you know what that intuition is? Okay. Why these algorithms, if you write down exactly the way to solve the problem, why they fail, is that I was actually talking to somebody, and I think this is going to be, I will take a minute to talk about it, okay? It is useful. In the 70s, people were trying to figure out how to teach computers to think like humans, with massive parallelism, artificial intelligence, and all that, okay? But now, I find more and more people try to think that maybe we need to start thinking like computers, program ourselves with step-by-step instructions. Okay? First do this, then do this, if this, then that. Okay? Our brain is far more powerful than the computer processor. On most tests, computers are completely pathetic. Especially, you know, like solving simple problems that don't require too much computation, that you recognize, you know solutions to. A lot of operations happen in your head kind of simultaneously, okay? So so that's what it means to solve problem by inspections. If I draw this for you, okay? Let me draw it here. Diode on or off? On, okay? So this should be pretty automatic for you. You connected the positive voltage, well, considering this is positive. You connected positive to P, you're gonna, well, sorry, I didn't say how much voltage. That was a trick question. Diode on or off? It was in my head, you know. Okay, so diode on, you connected sufficient voltage, okay? So, but like this, if I reversed it, you'd say diode off, okay? When you're getting used to those problems, by all means, do the assumption of an open circuit and then check it, okay? But when you get practice with the problems, you'll see it automatically. Alex, what's up?
Will we always be told the turn on voltage?
Sorry, what?
Will we always be told the turn on voltage?
Yes. You'll always be told to turn on voltage. If you are not told to turn on voltage, assume it's 0.7. But I believe we are disciplined and we have turn on voltages everywhere. And we're not going to sneak in a germanium diode with a turn on of 0.3 on you just to confuse you on the exam. Okay? We've been doing 0.7. And some textbooks do 0.6. You know why? It's really 0.65. Okay, closer for silicon. Oh well. All right, yes?
Just a quick question. Is it irrelevant if both definite or together?
No, it will not. And actually, you'll find that it is not on it. We covered it somewhat. They might come back to you on the final, but they're not by itself. IV curves can be. We used IV curves a lot. Yes.
Professor David said we might have definite and ordinary circuits on the exam. Regarding the IV curves.
So we made the decision that no, for sure. Okay. In my mind, there was never a doubt that we weren't going to have them, but you know, but it was kind of ambiguous. So they're not on the exam. Definite and orthogonal completion. Yeah.
So focus on the large signal model, not like ideal or anything.
Yes, large signal model. When is large signal model and ideal pretty much the same? when are they pretty much the same? When you're dealing with enormous voltages. If you're rectifying a 2000 volt wave, right? It doesn't matter whether you subtract 0.7 from 2000 or not. Okay, that becomes irrelevant. That's where ideal voltage model for the diode comes in for large voltages. Okay, which it happens, like say in this thing. Okay, you see this AC to DC adapter, right? A lot of voltage is coming in onto those diodes when they're as they're getting rectified, right? So then you can just treat them as ideal, right? Because 0.7 is tiny in comparison to 200.